most interesting part of engineering is the wheel, where we transmit our motion directly to it and which help us to move from one point to another. But in that process also, when we try to refine everything, when we went for precision, accuracy, and efficiency, at that time we came up with a this with an element, mechanical element, named as gear. So gear is something like wheel only, but there are some structures beyond its sides. There are several structures where other gears can come in contact and make motions. So what happens is that the power distribution comes in controls. There will be no maximum power, no minimum power. There will be optimum power and fuel savings and everything. Everything started to go with line by line. So how it started actually? So fundamentally of the gear is nothing but will have a teeth and teeth and another gear will also have a teeth. Both the teeth will come contact to each other and the motion will be transferred in terms of rotational energy or rotational motion. We cannot say rotational energy. There's no such word. There are kinetic energy and your uh, potential energy in terms of mechanical. But there are also thermal energy also. So what happens is that in Spur Gear helps to transfer from motion from one end to another end, another one point to another point by using its teeth. Now you can see there are what we have actually. We have pitch diameter, pitch point, pressure angle, velocity ratio. Now what happens is that pitch angle is nothing but at what angle these teeth are aligned. Okay, and diameter is the diameter, pitch diameter. So diameter at what the gear is made of the this one, or you can see the we can say tell the optimum diameter of the section. Next is the pressure angle, at what angle, that is this one. This things defines, as well as this landing zone defines the slanting, and the landing zone defines what could be the pressure angle, maximum pressure angle that a gear can take. Velocity ratio which help us to understand what velocity will be transferred. Okay, so material consideration, most of the time we go for alloy steel for I mean, if you are demanding very much in very much applications like aerospace, automobile, we go for alloy steel, but it is a very much I mean for precision making and everything. But here comes the durability. If you need all the things something, all everything you need for going, you need to go for case hardening steels, which will actually help us to get this type of steel, this type of gear to be in a good way. Now, we also use minimum carbon steel like mild steel also. That very rare. Okay. Now, optimization technique. If the contact ratio should be more than 1.2 or the same to 1.1, and ideal ratio should be 1 to 2. That means and higher ratios. Now, what does it mean? Now, you can see that gear contact ratio it should contact with one of the gear 1.2 times. That means one time it will contact, will come in contact, and second time it should stay for a while. That's why it is given 1.2. So for load sharing, because you have to share the load, and this gear have to be rotated. And ideal ratio is 1:2 or 1 to 2, because if the gear rotates one time, the other gear will rotate one time, or it may be if gear plus one time, the other gear will rotate two times, or more than that. It also happens. But 1:2 is the is best for majority consideration. Manufacturing, as I told you, we use softwares, we use guidance by ASME, and there is a AGMA, American Gear Manufacturing Association, which gives the guidelines how to use. Yes, you can see the reference books are nothing but the guidelines, and it gives the design standards what you need to follow. Now, what is the advantage? Gearbox, aircraft engines, conveyor is, as I told you, where motion will be transferred with a less and transferred in a controlled way, not in an uncontrolled way. So what then we have to go for this type of things. Okay, we need to go for gear, which actually help us to give positive, positive energy motion transfer. But we don't use belt because don't use so belt also. But sometimes we use belt, but not in all cases because uh, there's a friction which comes in a contact. But here also friction comes in a contact, but there's a positive lock due to the geometrical aspects, and that makes a USP for gears. And this is what we do. No noise, which this is the challenges with Spur Gear noise, and that is generated. If I high load, the tooth machine can go down. For low speed, it is good. Okay. For high load gear, it is good, but it's not good all the time because there is a is a consideration of material. What material will be considered? Sometimes if you give a high load and you design a proper way, but you consider material not to be that what you need, so that would be a mess up. So that is what you have to see. But it is good for lower speed and high load. That means maximum force and minimum speed. Okay, thank you.